In this application, the circuit looks like similar to the previous one in application 7, but the difference is that the three lamps here are not identical. So consider a circuit represented in the adjacent figure. The three connected lamps are not identical. The voltage across the terminals of the dry cell is 12 volts and the voltage across L3 is 4 volts. Now determine the voltage across the terminals of each one of the three lamps and the switch K. In this case, switch K is open, so you know the rule. You open a switch is equal to U battery, which is in this case 12 volts. Determine the voltage across the terminals of each of the three lamps. As long as we have an open switch, U1, no current flows through the circuit, so U1 equals 0 volts, U2 equals 0 volts, and U3 is equal to 0 volts. Why is that? Because we have open circuit, so the receivers, when the receivers do not receive electric current, this means that they don't have voltage. Open circuit means no current flows, so no voltage. No current flows, so we have no voltage to the receivers. These are receivers. No voltage for only the receivers. Now determine the current that flows in each one of the three lamps. We just mentioned it. I1 equals 0 amps. I2 or 0 milliampere, doesn't differ in this case. 0 amp. I3 is equal to 0 amp. Okay, why? Again, because open circuit. The main switch that is in series with the battery is open, so it takes control of the functioning of the whole lamps. Now, concerning the second case when the switch is closed, the current I is 600 milliampere. And the current I1 is 350 milliampere. The question now is determine the voltage across the terminals of each one of the lamps and the switch K. So as we discussed before, L1 is in parallel to the battery because closed switch. So L1 is in parallel because a closed switch acts like a connecting wire. So we consider that the two terminals of the lamp L1 and the battery are connected to each other. That's why we write the statement is U1 is equal to U battery, which is equal to 12 volts. The reason is law of uniqueness of voltage in parallel grouping. What about U2 and U3? Given that U3 is equal to 4 volts, we have this 12 volt. So again, this is U3 equal to 4 volt. Now we want to find U2. So far we found U1 to be equal to 12 volts. We still have, and U3 is given, so we still have to find U2. You can see that L2 and L3 are traversed by the same current, and one terminal of L2 is connected to one terminal of L3, while the other is not connected directly to it. That's why L2 and L3 are in series, so the voltage, the equivalent voltage of the series grouping is equal to the sum of voltages. And as we discussed before, as a grouping, as a whole grouping, this grouping is parallel to L1. So we have to say, in the first place, we have to divide our work into two steps. We have to say U for the series grouping, just as we did in application 7. U for the series grouping is equal to U2 plus U3. This is due to the law of addition of voltage in series grouping. So we have the law of addition of voltage in series grouping. Now as a grouping, it is parallel to U1. So that's why in the other step we write that, but U for the grouping, I'm going to abbreviate it just here instead of writing series. Okay, but you have to write it completely. U grouping is equal to U1 equals to 12 volts due to what? The grouping is in parallel to L1, so due to a law of uniqueness of voltage in parallel grouping. So law of uniqueness of voltage in series grouping, in parallel grouping, because the grouping is in parallel to L1, in parallel grouping. So now I have U for the grouping is 12 volts. I substitute it in the first equation here that we wrote. So we have U grouping and we have U3. So we obtain an equation with one unknown, which is U2. Then now substituting, then we have 12 volts is equal to U2 plus 4 volts. U2 is equal to 12 volts minus 4 volts, which is equal to 8 volts. So in this case, we do not divide by 2 as we did in application 7 because the lamps are not identical. We have to substitute in the laws, and of course there must be an extra given here, like the one about U3 equal 4 volts, okay? Now again, given, now concerning the current, you have that I is 600 milliampere, and that I1 is equal to 350 milliampere. Alright, 350 milliampere. So we have only to apply the law of addition of current in parallel grouping. So we have I that reaches point A and is distributed among or between the two branches. So we say that I is equal to I1 plus I2 by the law of addition of current in parallel grouping. So in parallel grouping, and we do the substitution. I is 600 milliampere. I want 350. We still need to find I2. So I2 is equal to, we take 350 to the other side, we have that it's 600 milliampere minus 350 milliampere. It's equal to I2, which is equal to, in this case, it's equal to 250 milliampere.